Good day, educators and learners. This video will show you what are the statistical tools that can be used in research. Statistical tool in research. Quality analysis, which as the term implies, is not based on precise measurement and quantitative claims. Social analysis is frequently qualitative because the understanding of the phenomenon under study may not require quantification or because the phenomenon itself does not lend itself to precise measurement. While the quantitative analysis, which is employed in data that have been assigned some numerical value, quantitative analysis can range from the examination of simple frequencies or frequency distributions to the description of events or phenomena using descriptive statistics and to the investigation of correlation and causal hypothesis using various statistical tests. In choosing the test, there are three questions that should be asked. Number one, for the data, what level of data measurement should be used in analyzing? 2. For the samples, how many samples do you have? 3. For the purposes, what is the purpose of your analysis? Most data fall into one of two groups, the numerical and categorical data. When we say numerical, these are quantitative or can be measured. There are two types of numerical data. We have the interval and ratio. When we say interval, these are the zero is arbitrary. The best measure of central tendency are the mean, median, mode. Then the best measure spread are range, variance, standard deviation, and interquartile range. While ratio data, this is the zero is not arbitrary and means none best measure of central tendency are the mean, median, mode. Then the best measure of spread are range, variance, standard deviation, and interquartile range. When we say categorical data, these are qualitative or can be grouped. We have two types of categorical data, the nominal and ordinal. When we say nominal, these cannot be arranged in any particular order. The best measure of central tendency is mode. Then the best measure of spread is none. While the ordinal data, these can be arranged in order. The best measure of central tendency are median and mode. Then the best measure of spread is the interquartile range. Examples for the four levels of measurement of data. So for the nominal variables are sometimes numeric but do not possess numerical characteristics. Some of the numerical nominal variables are phone numbers, student numbers, etc. Therefore, a nominal variable can be classified as either numeric or not. So for the characteristic of the nominal variable, the responses to a nominal variable can be divided into two or more categories. For example, gender is a nominal variable that can take responses male or female, which are the categories the nominal variable is divided into two. For the ordinal, there are also two main categories of ordinal variables, namely the match and unmatched category. The match category, each number of data sample is paired with similar members of every other sample concerning all other variables, aside from the one under consideration. This is done to obtain a better estimation of differences. While the unmatched category, it is also known as the independent category, contains randomly selected samples which variables that do not depend on the values of other ordinal variables. So for example, position in a race, if it is first, second, third, or fourth rank. Then third, examples of interval variables, temperature measured in Celsius or Fahrenheit, time, generation, age range, etc. For the ratio variables have absolute zero characteristics. The 0 point makes is what makes it possible to measure multiple values and perform multiplication and division operations. Therefore, we can say that an object is twice as big or as long as another. Let us have the statistical test, purpose, and assumption. Under the statistical test, we have the measures of central tendency. So we use the mean median mode. For the purpose, it is typical value or a representative value of a mass or quantitative data. For the assumption, it is appropriate for interval and ratio variable, and it is also for ordinal data, and it is also for nominal and interval data. Another statistical test is the measures of dispersion. We have the range, quartile deviation, and standard deviation. The purpose of the measures of dispersion, the degree of spread or variability of a given set of data. The assumption for the measures of dispersion, describing the extreme scores, analyzing the semi-interquartile range of scores or item values, deviation of values from the mean. For higher statistical inferences, like those involving coefficients of correlation and standard scores. The third statistical test is the measures of location. So these are the percentiles, quartiles, and the deciles. Now, the assumption for the measure of location, the percent of cases below a particular rank position, analyzing the value of the variable based on quarter position, analyzing the value of the variable, the percentage being taken in units of 10. Then the fourth statistical test, we have the descriptive measures. We use the percent and proportion. We use the assumption of standardizing for size, looking for a subgroup in relation to the whole, and comparing the relative size of a subgroup as against another subgroup. Another descriptive measure in statistical tests are the skewness and kurtosis. The assumption, The categories must be mutually exclusive and exhaustive, describing symmetry or asymmetry, normality or abnormality, describing pickedness, ordination, nature of the distribution, hump, and tails. The fifth statistical test we have, number one, is the Pearson R. The purpose, descriptive whether or not variables are correlated, describe the nature and extent of relationship between and among variables. The assumption for the Pearson R, measure of linear correlation of two variables which are either ratio or interval. The second measure of correlation is the Spearman. The assumption, the correlation between two ordinal variables. The third is the phi coefficient. Correlation between two real nominal dichotomous variables. Then the fourth, point biserial. The assumption, the correlation between a real dichotomous variable and interval variable. Then the fifth, we have the multiple correlation. The assumption is the correlation between a real dichotomous variable and an interval variable. Then the sixth correlation is the partial correlation. The assumption, correlation of two variables partialing out the influence of a third variable. The seventh correlation is the multiple regression. The assumption, describing the correlation among variables, identifying the cause and effect relationship. Then the sixth statistical test, we have here the students' one sample chi sample test. The assumption, testing a hypothesis about the mean of a normally distributed population using a one sample group. The second inferential statistic, we have the t-test of correlated means under the Wilcoxon test. The assumption, the significance of difference between two. Then the third inferential statistic, we have the t-test of independent means by Mann-Whitney-U test. The assumption, the significance of difference between two independent groups. The fourth inferential statistic, we have the F-test one-way or the Kruskal-Wallis test. The purpose, finding significance of difference of variations using K samples. The assumption, significance of differences among three or more independent groups, data in the strength of interval measurement. Then the fifth inferential statistics, we have the F-test two-way or the Friedman test. So the assumption, the function of two-way F plus the interactive effect. Then the sixth inferential statistics, we have the analysis of covariance. The purpose, using the K-sample plus interaction effect. The assumption, an extension of ANOVA, allowing for the correlation between initial and final scores, covariance analysis, effects, adjustment in the final score or terminal score, which allow for differences in some terminal variables. Let's try this. What statistical tool are you going to use? The question, do you like to describe status of phenomenon? If the answer is yes, use the central tendency or variables or other descriptive measure. If the answer is no, so let's move on with the second question. Are you comparing one distribution of scores to another? If your answer is yes, use the chi-square or critical ratio. But if the answer is no, move to the next question. Are you comparing the means of two or more groups? If the answer is yes, how many means are you comparing? If two, use t-test or analysis of variable. Next, are you comparing the means of two or more groups? If the answer is yes, how many means are you comparing? If the answer is 2, use t-test or analysis of variance. If no, use analysis of variance. Then, if the answer in comparing the means of two or more groups is no, are you trying to determine how closely performance on what variable predicts performance on another? If the answer is no, think again. You either need a statistic not covered in this two chapter or have made a mistake in your thinking. If the answer is yes, are you using a combination of two or more variables to predict an outcome? If the answer is yes, use multiple correlation. You want to measure the extent of influence of predictor variables to the criterion variable, then use the regression analysis. But if the answer is no in using the combination of two or more variables to predict an outcome, are you trying to determine a curvilinear relationship? If yes, use beta coefficient. But if the answer is no, are you holding a third variable constant? If the answer is yes, use partial correlation. But if the answer is no, use person correlation. Thank you for watching. I hope you learned something new. Don't forget to subscribe, like, and share this video. God bless us all.